Section 3. Applying multi-threading features to your project. In this video, we will talk about working effectively with organized library modules. It's time to refactor our code. We're going to organize it nicely into library modules so that in the next video, we can start running our code in multiple threads. The first thing I'll do is open the Project Explorer and create the files that we're going to have in our library. So first we need our lib.rs and export all the modules that we're going to create. I'm going to make 4 modules: args for argument parsing, read for our reading of data, stats for our outputting of statistics, and write for our writing of data. The last thing that we need at the top level of our library is the constant, so I'll paste the constant in. Now let's add a module file for each of our modules. Each of the files will be the name of the module plus .rs. Okay, I skipped to all the files being created. Now let's go look at lib.rs. The module's resolved now. They're all empty, so let's go and get something and put them in them. Let's fill out args.rs first. We need the argument parsing imports, and then let's make a struct. I don't have to do this. We could return a tuple of the values, or we could just return the raw match object, which could contain anything. But I don't really want to keep changing the return value of my function if I change the options. So I'm going to collect everything in this struct. And since I have a struct, I might as well go ahead and make an associated function to do the parsing and return the struct. And then everything's all tied together neatly. So I'll go back to main and grab all of the parsing logic here and cut and go back over to args and paste it inside of our function. And we're nearly there. The logic really doesn't have to change. We do need to return our struct with the information. So I've got infile, outfile, and silent. But infile and outfile are supposed to be strings, so let's convert them to strings right here. We'll just call toString on the borrowed string slices. Let's close the project view so you can see everything. And let's go back and recap. So we've got our imports, we've got a struct to contain our information in these fields. We've implemented the parsing logic in an associated function that returns a new args. We left all the logic the same, and at the end we returned our args struct. So now that our args module is complete, we can move on to our read module. Let's grab some of these imports from main and copy them and paste them over in read. We'll clean out the ones that we don't need in a bit. So put those here. We also need inside of our own crate the chunk size so we know how much to read. And if we go through these, we don't need buff writer. We don't need error kind. And we don't need write. Now let's go down and make our read function. Let's take infile as a borrowed string slice because we're not going to change it. And since we can fail, let's return a result of what? A vector of U8. So that's our vector of bytes. Then let's go back to main and grab our reader logic, cut that, and come back to the read module, paste it into our read function. Clean this up here. And then let's go back to main and see what other read stuff we can get. Okay, creating the buffer that we're going to read into, we need that. Let's go paste that in. And then let's go back again and grab the actual reading call and take that, put that in. We'll return an OK with our vector at the end. But let's figure out what to do with these breaks up here first. Since we're returning a vector, we can return a 0-size vector and deal with the breaking of the loop out in main. For the error case, we can replace the break with returning the error. So we need to go and instead of ignoring the error, capture it, and then we can return it, and we have to rewrap it in error. But this logic is exactly what a question mark does. So let's simplify this down to just the question mark. And we need to also go remove the match from in front. There, now that should work. Now we can create a vector out of the populated part of the buffer that has our bytes in it and return that. Now our read function is done. So let's go work on our stats module. First, let's go to main and grab everything that has stats output in it somewhere. We'll just copy the whole thing. And then let's go over to the stats module and put it in a function. Let's call it stats. What are we going to need? We're going to need silent, which is a Boolean. We're going to need num red, which is a usize. And then we're going to need the total bytes. Now this needs to be a mutable reference to some total bytes outside of the function. And then last, we need a Boolean to indicate whether this is the very last statistics output when we need a new line. Now let's go ahead and paste the bits from main. And then let's delete the part from the writer that we don't need. And then let's fix the indentation here on the second block and comment it out for the moment. We'll come back to it in a second. For now, let's go up to the top of the function. We need to dereference the mutable value through the total bytes reference so that we can increment it by number read. That's our actual statistics collection. And then we can re-implement that logic we had in that last block, where if this is the very last time through, then we want an extra print line. And that's the only difference in that last block, so we can get rid of it now. Okay, so our arguments are silent, numRed, total bytes, and last. We take our total bytes, dereference them, increment them by numRed. If we're not silent, we print out our progress. And then if this is the last time, we print out an extra new line. Now we can go back to main and clear out the stats parts. So this top block and then this bottom block. And we don't increment total bytes out here anymore. So we're ready to move on. So we've got this part here. Let's copy this and go work on the write module. I'll make some room for the imports that we're going to have and then start our function. So write is going to take an out file and a buffer, which is going to be a slice of bytes. And then our return value is going to be a result again. But this time we're going to be Boolean. I'll show you what that's for. So let's paste this in and then go back to main and delete that and grab the writer code. We'll cut that and go paste that over at the top of our function. And then let's go back to main and grab these imports, cut those and go paste those at the top of our module. We'll clean those up in a little bit. But first let's talk about what we're returning from this function. So a result of bool means something. After we create the writer and then do the writing, we return some success with a Boolean. So let's say that true means keep going. So here's our OK true. That means in our error case, we'll put false, meaning stop cleanly. Something happened that's not an error we want to crash for, but we do want to notice it and stop cleanly by returning an OK false. Now let's go and clean up the imports. So we don't need buff reader, we do need error kind, read we don't need, and then result and write are all good. Which means all we have left is main. So let's do our import of standard IO result because we need to return that from main. Let's clean this up. And it's finally time to go and import all of our new modules that we wrote. We need to use pipe viewer. We can't use crate here because the binary and the library are separate crates. I'll follow the convention of accessing functions through their modules. And we're finally ready to call that associated function and get an args struct. Now we can go down into our main loop. What are we going to do? First, we're going to make a buffer. We're going to get it from our read. We're going to match on that because it returns a result. A result of what? Well, of a buffer, a vector of something. So you remember that special case? So if it's empty, let's add a guard here for the empty case, then we want to break out of the loop. Otherwise, if x isn't empty, then we want to keep it. And if there's an error, we don't really care what it is. We just want to break out of the loop because we're done. And then after reading, we collect statistics and output progress. So we call our stats function. We pass it all the arguments, so silent and length, the mutable reference to our total bytes, and false because this is not the end. And then we can write out our bytes. So we call our write function, we give it our out file reference, we give it a reference to our buffer, and then since it returns a result, we can use the question mark. And if that succeeds, then we have a Boolean. So if it is not keep going, then we want to break. And then finally, outside the loop, we're going to call stats one more time. We'll give it silent. We don't have a buffer, so we'll put 0. The same total bytes, and then we'll put true because this is the last stats. And then we're done. So we exit with an OK. All right, let's try things out. First, let's build things to make sure. Uh-oh, we got a problem. Oh, so we tried to use numRed in write, but we don't have numRed in write. What do we have? Well, we have this buffer here, and we already know that it's sized exactly correctly. So let's take off the slicing and just give it the whole thing. So let's save that and go back and build it again. So run cargo build, and great, this time it worked. Let's clear the screen and echo Apple into cargo run and then output that to a text file. Okay, let's do that. We've got 6. That's good. That looks right so far. Let's look and see if the file really exists. Okay, still good. 6 bytes. Does it have the right contents? Yes. All right. Our refactoring job's looking pretty good, but let's be sure. Let's echo another string here and just run it to cargo run. Okay, that looks good, like we expect, the double output there. So what if we take yes, and let's pipe that to cargo run, and then pipe it out to head. Let's give it 10 million, and then redirect our standard out so that we don't have all the Y's. So we just get our progress, and fantastic. I think we're good.